Well, this is a difficult question, and being a higher number in the multiple choice, you're generally going to find the ones towards the end. You're going to need to spend your full 1.8 minutes on some of these questions to get them right. So quite a difficult one, but it's really sort of digging down to your understanding of pressure, volume, number of moles of gas, how Avogadro and the ideal gas law kind of links all those things together. So we've got our initial conditions, and then we've got some changing conditions. And if you read the stimulus, it tells you very clearly the only thing that can get changed is the temperature of the air in the sealed chamber. That's the only kind of lever we've got to pull. And so that's going to have an effect on those other things. Well, the number of moles of gas can't change because the chamber's sealed and the balloon is tied off, and we're told that no gas can come or go. And so really now we're just thinking about pressure and temperature and how those things are related. So let's have a look at B. First of all, our temperature's gone down, but our pressure has gone up. Well, if we've cooled it down and we haven't changed the number of moles of gas, then the pressure would definitely not have gone up. So that kind of puts B out. For a similar kind of reason, if we look at C, the temperature's gone up, but the pressure hasn't increased. Well, that can't be, so that knocks out C. And so A and D are looking pretty good at the moment. And what knocks out D is, if you look really carefully, the balloon is the same size and therefore the same volume as the initial conditions, even though the pressure has gone up. Now, the temperature's gone up and the pressure's gone up as we'd expect it to do. But have a look at this. I put a balloon in a soda stream bottle because that's something I could add pressure to. And you can see as the pressure, external pressure increases, the volume of the balloon goes down. And so that makes D kind of appealing, but that's the reason that D is wrong. And now we're left with A. Okay, so the temperature's gone down, the pressure's gone down, the external pressure's gone down. That makes sense. So what happens to the balloon? We'll have a look at this. When I release the pressure in the soda stream bottle, the balloon increases in volume. And we can see an increase in volume there. So all of those things tie together. Temperature's gone down, the pressure in the chamber's gone down, the volume of the balloon is increased. And of course, it's the same number of moles of gas in now a larger volume, so the pressure inside the balloon has to be less, and that's why it's A.